Okay, so let's talk about design property system. So you have to design a property system for a parking lot, and you have three different kind of cars, which is big, medium, and small. And you just basically just have to return if there's any spot left for the big and medium and small. So this will be easy just using the three different variable. I'm just for big equal to 0, medium equal to 0, and small equal to 0, right? Then I'll initialize my big equal to big, this medium equal to medium. I mean, these are n, by the way, sorry. And these are s equal to small. So when I traverse the add car, right? So I basically have to check my car type. So car type represent 1, 2, and 3. 1 represent big, 2 represent medium, 3 represent small, right? So I'm going to just check. So if car type is actually equal to 1, I'll have to return. So I decrement my b, and I'll have to check if the car spot left is actually greater than 0, right? So same thing for the equal to 2, same thing for the median, decrement the b greater equal to 0. And if car 5 equal to 3, I'm going to do the same, decrement s greater equal to 0. So anything else you have to return false. This is actually avoid the random input for a car type, and this will actually works. Yes. So there's a trade-off for this one. So let's talk about the time and space complexity. So this is actually all of n for the space, to be honest. So when you traverse the egg car, right, this is all of n. Like you go from top to the bottom. This is actually like loop, right? Like you check this one, check the car type equal to 1. Okay, if car type is not equal to 1, you check for car type equal to 2, and so on, right? So this is all of n. So I'm just making sure you know what I meant. So for this solution, this is all of n, right? So time complexity for air car is equal to all of n, space constant. So I'm just going to comment this out, and I'm going to write another one, and this is actually have a better time complexity, but you also have a trade-off for the space. So just copy and paste. All right. So I'm going to use in array. So in array, there's going to be cars. I'm going to just create new ints, and this is going to be 3. You have a 3 spot for this, be a medium and small, right? So there's a better way, like just initialize this. So I'm not going to just say 3. I'm just say cars. It's actually put new int, and then I'm going to say big, medium, no. So this is the same thing. Say cars 0 equal to big, cars 1 equal to medium, cars 2 equal to small, right? So when I actually traverse the public at car method, so basically I just have to return car car type. You have to subtract 1. This is because the car type is starting from index 1, not a 0, and then we only have 0, 1, 2, right? So I have to decrement my car, and actually greater to 0 in this case. So I decrement the car spot left. So if the spot is actually greater to 0, you return true. I also return false. So this is actually just making sure the car type is actually 1, 2, 0, 1, 2, and 3, right? So we don't have a random input for this one. But this could be a bug, but it doesn't matter. So in this case, the time is actually all of 1 for the add car, and the space is actually all of n, right? So just write down so you know the idea. So in this case, you know the index, so you just go into the cross array right away. So this is all of 1. For the space, yeah, the cross array is all of 1, right? So this will be the solution. And I hope you get it, and this is easy, and I'll see you next time. Bye.